Hello everyone. Today we are going to learn about pipelining and its hazards. Now, what is pipelining? Pipelining is a technique used in computer architecture to increase instruction execution speed by overlapping multiple instruction phases similar to an assembly line in a factory. Now, imagine you are building a car alone. You do everything step by step. The process is slow, right? Now, imagine a factory where multiple workers handle different parts at the same time. This process is much faster than the previous process. That's exactly how modern processors work using a technique called pipelining. In today's videos, we will clearly understand what is pipelining, why it is needed, 5 stages of pipelining, hazards in pipelining and how to solve them. Let's get started. Now, what is pipelining? Pipelining is a technique in computer architecture where multiple instructions are executed simultaneously but in different stages. For simply we say pipelining is equal to overlapping execution of instruction. Why it is works? Every part of the process stay busy. While one instruction is being executed, another is being decoded, and third is being fetched. No stages sits idle. Then, uh, then we say we have 5 steps to execute an instruction. The first instruction is fetch, the next one decode, the another one execute, then 4 and 5 is memory and write back. In a non-pipelined process, instruction 1 completes all 5 stages first. Only then instruction 2 starts. The result of the non-pipelined process is slow performance and hardware is mostly idle. In with pipelining solution, each stage works on a different instruction at the same time. For example, instruction 1 execute a stage, and instruction 2 decode stage, and instruction 3 fetch stage. The result of the with pipelining process is faster processing and better CPU utilization. Then the five stages of pipelining. Let's understand 5 stages clearly. In instruction fetch, get instructed from memory. In instruction decode, understand instruction read and register. In execute, perform operations. In memory, access memory if needed. In write back, stores the result in register. Now, throughput versus latency. Important concept for exams. Latency is time for one instruction. Throughput is number of instructions completed per second. Pipelining increases throughput, not latency. For example, highway with more lanes, more cars pass, but speed of one car does not change. The advantages of pipelining is increased throughput, better CPU utilization, higher clock speed, efficient performance. Now, challenges. What is the challenges? Hazards. Now comes to the most important part of the hazards. Hazards are problems that stop smooth execution of pipelining. The first is data hazard. When one instruction depends on the result of the another, the data hazard is occurs. For example, instruction 1, R1 is equal to R2 plus R3. Instruction 2, R4 is equal to R1 plus 5. Instruction 2 need R1 before I1 completed. This time, in these operations, data hazards occur. Then move to the control hazards. Happens due to the branch instruction. CPU does not know which instruction to execute next. In this type of problems, we can face the control hazards. Let's move to the structural hazard. When two instructions need same hardware resource, the two instructions need memory at the same time. The hardware resource is busy, and this causes the structural hazards. Now the solution of the hazard is, the first solution is forwarding. Forwarding means directly pass results from one stage to another. Avoid waiting. And the next one is stalling. Stalling is create a bubble, pass pipelining until data is ready. The required data is ready. Next, the branch prediction. Branch prediction is guess next instruction in branch, improve the performance. Next, the key takeaways. Pipelining is equal to parallel execution in technique, improves the throughput, uses 5 stages. Which are the 5 stages? Instruction fetch, instruction decode, execute, memory, write back. And hazards are data hazards, control hazards, structural hazards. Solution for the hazards is forwarding, stalling, and branch predicting. So that how modern CPU achieve high performance using pipelining. If you understand this clearly, you are already ahead in computer architecture. Don't forget to like, share, and subscribe for more easy explanations. Thank you.